Hi, my name is Chikara Kakizawa. I'm an applications engineer in the Clock and Data group at ON Semiconductor. Today, I'll be talking about the GreenPoint Phase Noise Explorer tool. The GreenPoint Phase Noise Explorer enables an interactive design environment for advanced phase noise and jitter analysis of clock tree designs in 7 easy steps. These include phase jitter contribution, phase noise, and spur plotting. The tool gives many advantages to our customers by simplifying system timing analysis for phase noise and jitter parameters. This results in a faster development cycle and implementation of your design. The tool also allows you to examine parts beyond the frequency range that is specified in datasheets. Having access to these features will increase your confidence when deciding to use our products. Phase noise is the frequency domain representation of random fluctuation which translates to additive unwanted energy. It is measured at specified frequency offsets relative to the carrier frequency. Ideally, the device would have a sharp spike at the carrier frequency and none of the sidebands shown in the diagram. Phase noise is observed using a phase noise analyzer and then translated to the time domain by integrating the area under the curve to obtain phase jitter. Spur is an anomaly resulting from clock signal distortion and appears as a sharp spike in the frequency domain, which is equivalent to deterministic jitter. To minimize the effect of these losses, a filter can be utilized to corresponding integration range. In order to access the program, go to www.onsemi.com, our homepage. You need to first log into your MyOn account to use the tool. If you do not have an account, please register at this time. There are 3 places to load the tool. The first is from the homepage in the bottom left area. The second is from the product catalog list, and the third is in the individual products page. The first step after loading the tool is to select which type of clock component you will be adding from the drop-down menu in step 1. The block diagram shows how the 2 types differ in a clock tree. Then we will decide to create a new part, select from a catalog of on-semiconductor parts, or browse the computer for an existing model. The first option is to create a new part from phase noise values found on standard datasheets. This is useful for adding other supplier parts for comparative analysis, visually observing characteristics for older parts where a plot is not provided on datasheets, and/or analyzing performance in alternate carrier frequencies. Part creation is done with the very left button in step 1. Notice that once the clock type has been selected, the buttons will be enabled from their previous grayed out state. In order to ensure accuracy, you should enter all the offset frequencies and the corresponding dVc per hertz values as seen here on the screen. Double-click each cell to enter in a value. The software will recognize SI notations such as K to denote kilo. To add or subtract rows, the Add and Remove buttons can be used. The Sort will reorder the list in ascending order of offset frequency, and Refresh will replace all of the data values with random data points. To revert to the original data, the component must be reloaded. Be sure to title it with a unique name and add an operating frequency, F carrier value as well. It is recommended to extend the noise floor by adding a much higher value of offset frequency, like 40 MHz in this example, and then populating noise with the last value on the table. You can also add individual spurs from this panel by clicking the Spurs tab and entering an offset frequency and the dBc per hertz value. Using the Step 2 panel, the X and Y axis boundaries can be adjusted to better fit the plot. There are additional display options like showing all of the input data points. Hit Apply to implement the changes. Now we will add filters to the system. In the Add Jitter Filter box, up to 3 filters can be added to the plot to observe their effect on random jitter and deterministic jitter. Check the box next to the filter to enable, and then select which one you would like to implement from the drop-down. For the tutorial, we will be using the Brickwall 12K to 20 MB and the All Pass. When you click Analysis, a new panel will pop up with additional options. Let's check Filtered Phase Noise, Fill Integration Area, Phase Random Jitter, and Phase Deterministic Jitter. This is what your final plot should look like. The red area corresponds to the brick wall, and the blue area is the All Pass. The difference in jitter can be seen in the information box on the top right corner. The dashed line is from the filtered phase noise option, and the filled in area is from the fill integration area. The component model can be saved as a .dbc file by clicking this button. This can be loaded in Step 1's Browse function at a later time. Finally, a report can be generated as a .pdf file. For the second part of this presentation, we will utilize the catalog part function as well as the combine and sum functions. The Phase Noise Explorer includes a wide range of parts from ON Semiconductor's timing products portfolio for convenient implementation. In Step 1, click on Catalog and find the NB3N51032. Make sure that the clock type dropdown has clock source selected. In the product family menu, pick clock generator as a type of source. In the variant box, you can choose the operating frequency and the voltage. We will select 200 MHz and 3.3 volts and hit OK. Next, change clock type to clock buffer and hit Catalog again. Select the Eclipse Max product family and the part number NB3N108K. The variant is 3.3 volts HCSL, and for frequency, type in the carrier frequency of the clock source, which was 200 MHz. In order to use the sum and combine functions, the component of the clock tree must have the same operating frequency. Click OK. You can see that this new part was created in its own tab. There are two useful tools for phase noise analysis. The combine function will place up to 5 component plots onto one plot for easy comparison. The sum function will take the power sum of 4 components in a clock tree and create a new plot of the result. The residual jitter of the entire clock tree can be observed by a new green line. Remember that each clock source and clock buffer must have the same carrier frequency for both functions. This is the resulting plot of the combine function. The red and blue boxes show the effective filter on each part. And this is the resulting plot of the sum function. The overall power sum is in the green curve, and you can see that this is not a straightforward addition. In this case, the red part dominates the phase noise contribution. Lastly, this is what the PDF report looks like. This concludes the workshop on Semiconductor GreenPoint Phase Noise Explorer. Thank you very much for your time, and for more information on this tool or our product portfolio, please visit www.onsemi.com.